This is section 2 of the trigonometry section of our aero engineering course. At the end of part 1, we determined that the hypotenuse of a 45-degree right triangle is equal to whatever the length of one leg is times the square root of 2. If the length of this leg is 1, the length of this leg is 1, then the length of the hypotenuse is 1 times the square root of 2, which is about 1.414, and a long string of other numbers there. If the length of this leg is 1 inch, then the length of this leg is also 1 inch, and the length of the hypotenuse is 1.414 inches. If the length of this leg is 2 inches, the length of that leg is also 2 inches, and this is 2 times 1.414 inches, or 2.828 inches. If this is 5 miles, this is 5 miles, and this is about 7.07 miles, I think. 5 times the square root of 2, anyway. Okay, if we use the trig function on our calculator, this is a 90-degree angle. Each of these are 45. This is what you call a 45-degree right triangle. We can remember our fellow named SOHCAHTOA. The first 3 letters of his name tell us that the sine of an angle like 45 degrees is equal to the length of the opposite side, which is B, divided by the length of the hypotenuse, which is C. Or we could say the sine of this 45-degree angle equals the length of its opposite side, which is A, divided by the length of the hypotenuse, which is C. And that shows us that A equals B. This leg equals that leg. And if you punch your calculator, if you say 45, hit the sign button, it gives you 0.707106781. Okay, that is the ratio, 0.707. That's the ratio of a leg of a 45-degree right triangle to its hypotenuse. We use Pythagoras' theorem to tell us that the length of the hypotenuse is equal to the length of a leg times the square root of 2. So if we just take this part of this equation and we replace A times the square root of 2 in our C position, see, because that's what C is equal to, so we'll just write A over, instead of writing C, we'll write what C is. A times the square root of 2 equals 0.707. So you have A divided by A, they cancel out, they equal 1. So you have 1 divided by the square root of 2 equals 0.707. And this is indeed the case. If you hit 2 on your calculator, let's see, 2, hit the invert x squared, which gives you the square root of 2. It says 1.414 and all that stuff, divided by 2, and it gives you that 0.707 number that we had here when we looked for the sine of 45 degrees. Okay, this shows us that the information we obtain using Pythagoras' theorem is harmonious with the information we obtain using the sine function on a calculator. Sine of 45 degrees equals 0.707. Okay, if you press the 4 and the 5 buttons on your calculator and then press the cosine, COS button, you'll see that the cosine of 45 degrees is equal to the sine of 45 degrees. Here we go, 45 cosine, there it is, 0.707, 106,781, just like the sine of 45 degrees. Why? Because the sine of this angle, this 45-degree angle, is equal to the opposite side, the length of the opposite side, side B, divided by the hypotenuse, C. The cosine of this same 45-degree angle is equal to the length of the adjacent side. Remember SOHCAHTOA. Cosine equals the length of the adjacent side divided by the hypotenuse. Here's the adjacent side to this 45-degree angle. There's the hypotenuse. A over C is what we have again. Same deal with this 45-degree angle. Its sine is equal to A over C. Its cosine is equal to B over C. Now, the sine and cosine of an angle are only the same when that angle is 45 degrees. It changes all around for our other angles. As we said earlier, the ratio of the sides and the hypotenuse of a 45-degree right triangle are 1 to 1 to the square root of 2. 1 inch, square root of 2 inches. Or we could also say it's square root of 2 to the square root of 2 to 2. The length of the hypotenuse is always the length of one of the legs times the square root of 2. So here it's A times the square root of 2. Here it's square root of 2 times the square root of 2, which is 2. Square root of anything times itself is the anything that it's the square root of. Okay, let's check with Pythagoras and see if this checks out with him. 1 to 1 to the square root of 2. Okay, Pythagoras' theorem is a squared plus b squared equals c squared. So a, we'll call this side A, 1 squared plus 1 squared equals square root of 2 squared. Is this true? 1 squared is 1. 1 squared is 1. 1 plus 1 is 2. Square root of 2 squared is 2. Indeed, it's true. How about this one? Let's check it out. A, we'll call this side A, this side B. A is square root of 2, so A squared is square root of 2 squared plus B squared, another square root of 2 squared, equals C squared. C is 2. So is this true? Is the square root of 2 squared plus square root of 2 squared equal to 2 squared? Well, square root of 2 squared is 2. Square root of 2 squared there is 2. That's 2 plus 2. That's 4. Equals 2 squared, which is 4. So indeed it checks out with Pythagoras. The ratio of the sides and hypotenuse of a 30-60 right triangle. Let's draw one here. That's a 30-degree angle. This is a 60-degree angle. That's our right angle. Okay, the ratio is 2 to 1 to the square root of 3. If we draw us another 30-60 right triangle here, oops, what we have is an equilateral triangle. This was 2, that was 1. That's square root of 3. Well, this is also 1. That's 2. And square root of 3. So 1 plus 1 is 2. From there to there is the same distance as from there to there and from there to there. This is an equilateral triangle because the length of each side is equal to the length of the other two sides. It's an equiangular triangle because that's a 60-degree angle, that's a 60-degree angle, and that's a 60-degree angle. This is a 30, that's a 30. Added together, they equal 60. Okay, this is a good illustration of how the short leg is half of the hypotenuse. See, the short leg is 1, there's the hypotenuse. Okay, let's use SOHCAHTOA to check this out. If you press the 3 and 0 buttons on your calculator, okay, 3, 0, and then press the sign button, the screen will read 0.5. Okay, as we can see from our drawing, the sine of 30 degrees, okay, here's our 30-degree angle. The sine of 30 degrees is equal to the opposite side divided by the length of the hypotenuse, according to SOHCAHTOA, or 1 over 2, and 1 over 2 is 0.5. That's why your calculator says 0.5 when you hit 30 and hit the sine button. Okay, if you press 60, then press 10, let's do that. 60, 10, you get 1.732050808. Okay, which is the square root of 3. If we press the x squared button, we get 3, because square root of 3 times square root of 3 is 3. That's the length from there to there. If this is 2 inches, that's the square root of 3 inches, and that's 1 inch. Okay, let's see if Pythagoras agrees. A squared plus b squared equals c squared. 1 squared plus square root of 3 squared equal to 2 squared. Is this true? 1 squared is 1, square root of 3 squared is 3, 2 squared is 4, 1 plus 3 is 4. Sure enough, it checks out. Okay, some other famous right triangles are the 3, 4, 5 and the 5, 12, 13 right triangles. 5, 12, 13. If you use Pythagoras' theorem on them, you'll see that 3 squared, which is 9, plus 4 squared, which is 16, equals 5 squared, which is 25. And this one checks out too. 5 squared is 25, plus 12 squared, which is 144, equals 13 squared, which is 169.